Okay, so today we're going to be looking at, before we were looking at arithmetic sequences. So that was when we were adding or subtracting the same amount every time. Now we're going to look at geometric sequences. So geometric is where you're either increasing it by the same percentage or decreasing it by the same percentage. So it's not technically the same amount. And today we're going to look particularly at compound interest. So just to help you understand, say we invested $100 into the bank and we got, say, 10% interest. So at the end of, say, the first year, we would have 110, okay? So then what compound interest is in the second year, they're going to take 10% of the $110. So that means you're actually going to add 11. So your new total would be 121. So it's not the same amount getting added, but it was still 10% of the amount. So can you see that's the difference between compound? So the amount getting added is actually increasing when it's compound interest. So the amount gets more, but it's still only 10%. So it's always on the new total. And that's what's different about it. And you'll see in a geometric sequence or recurrence relation, you'll see that what we're actually doing is we're timesing it by a number. And this R down here, we're going to work out how to calculate it. That will be a number that we're timesing it by. So when we have compound interest, we're still going to have the VO. So this is, if you want to write underneath this is our initial amount. And this is then the rule how to get the next value, yeah? So, and if you look here, we're going to times the value before. So when they refer to VN, that means the value before. And we're going to times it by a number. And this capital R is represented by a number. So you can see here, this is the rule for how we work out that number. So for the example I just said before, I would say 1 plus, now the rate I said was 10%. Okay, so really what I'm timesing the number by is 1.10. When I'm increasing something by 10%, I'm timesing it by 1.10. Okay, so let's have a look at this example. Okay, so looking at this example, so it says the following recurrence relation. So why is it called a recurrence relation? Because they're stating you a VO, which is the first amount, and then they're stating a rule that shows you how to get the next term or the next value. Okay, so the following recurrence relation can be used to model compound interest. So now that's what we'll look for when we're looking on our formula sheet. If they say compound interest, we'll go to the compound interest formulas. And it's a compound interest investment. So investment's like we're just putting it into the bank. So, and so when they say 2,000 here, that's going to be my VO, and that's why they've called that VO. And paying interest at 7.5% per annum. So, what does per annum mean again? Yeah. So if you look here, we're just going to explain this value here was in our formula was that big R. And so we find that R by going, we said 1 plus the rate over 100. So if you look, what they did is they said 1 plus 7.5 over 100, and that's how they got the 1.075. All right, so that's showing you how you can do that. We will sometimes see later, so because they said they'll always give you the per annum rate. So just remember, little r always equals the percentage per annum. So if we have to, and we'll see later, if we have to change it to monthly, we'll have to divide that by 12 and so on. But we'll do examples later when we get to that. Okay, so let's go through these questions. It says, use the recurrence relation to find the value of the investment after 1, 2, and 3 years. So often in our tests and in our exams, they're going to say show and that's where we're going to, so I'm going to pretend to say show. So we're going to use the recurrence relation to show the value after 1 year. So V1 would equal 1.075 times the one before, which would have been VO. So we'll do that, and then we'll get an answer. Now I'm going to have a quick show of you, and then V2 will be that answer times 1.075. So I'm going to show you how we can still do this recursively on our calculators. So I'll just pause it for a minute. All right, so let's go through that. So that ended up being 2150. Then what we're going to do is, and we times it by the balance before, and we got the next one. And then we found V3 by doing the number times the balance before. Yeah, let's get into the habit, because we said they're most likely going to say show, and yeah. Okay, B, determine when the value of the investment will first exceed 2,500. So because what we'd already on our calculator, we were already clicking through. So click it once. If you click one more time, you'll see that V4 was 2670.94. So we'll just say determine the value, just say in the 4th year, after 4 years. So after 4 years. Okay, and then it says write down the recurrence relation. So now we've got, they want us to write a recurrence relation. So if you remember, and I'll show you on your formula summary sheet where you're going to go now when it's compound. So hold on a minute. So your back page has a summary of all the formula sheets, because we don't want to keep flicking through all our notes to go. So this is what you're going to do now. And now remember that this column here is the recurrence relation column. And this, when you go down this spot, the middle section is the nth term. So when they're asking me to write a recurrence relation for compound interest, I will be going here, and this is what I've got to write out. And you'll see that the green, the R is highlighted green. I've highlighted because that means you have to put numbers in there. You have to work that out. If it's not highlighted, you would just write what it is. So for me to write, and I probably should have highlighted the principal, because you've got to write that in. So it says write down a recurrence relation if 15,000 was invested. So that's my VO. I've got to write that. And then we've got to write the rule. Now the rule requires us to know what R is. So we'll write out here, and here's how we work out R. So we're going to go 1 plus the rate over PPY over 100. Now, what is PPY? PPY means how many times in a year. In a year or per year that you're going to compound. So, for example, if they said monthly, we would, PPY would equal 12. Does that make sense? If I said quarterly, what do you reckon it would be? Quarterly PPY, how many quarters? 4. So it's 3 months, but 4. Okay, so they just want a yearly though. They just said write down, we just want a year. So if I was working out the R in this example, I'd do 1 plus the rate, which is 6. Now they're just saying per year, so PPY means once a year and over 100. So you'll end up with a value 1.06. So the recurrence relation will say 1.06 times the term before, so Vn. So you can see this was the only value I had to fill in, and same with that one. So there is the answer to the recurrence relation. Okay, so we also can find, so that was the recursion pattern for compound interest. But like if we're going to keep on just pressing enter, so say what if I said to the investment after 30 years, you don't want to be clicking on your calculator, enter, enter. So we have a nth term, means we can find the value at any time and we can use this formula. So here is like the nth term formula. So if you want to write, so you're finding value at any time. Okay, and we would use, when it's compound interest, we're going to use this. So you can see here, you've got yet that R again. So we're going to have to use that R, but now it's to the power of n. So there's a few things in here. So we might need to, so you can see here, n equals the number of compounding periods. So say if I had an investment and I wanted to know after 25 years, n would equal 25, yeah? So that's what this is. VO is still our original. Now, this formula written underneath, it's the same formula, but they've just written the actual how you find that big R. So you could probably go straight to here and fill it all in. All right. So here's, if you want to just change down here too, here's what, maybe change that to PPY. We refer to PPY. So if they say annually, PPY is 1. If they say 6 monthly, that's twice a year, so it's 2. If you see where I mentioned quarterly, 4, monthly, 12, they're the most common ones. And then often fortnightly is another common one, because lots of people get paid fortnightly, so then loans and investments are worked out fortnightly as well. All right, so don't stress too much about this stuff. It's just a little bit of extra. We're mainly looking at this. So let's go do some examples. Okay, Brian borrows $5,000 from a bank. So start writing things like, so it triggers you, that's a VO. He will pay interest at a rate of 4.5% per annum. So under that, that's our little r. Now it says let Vn be the value of the loan after n compounding periods. So that just means the value at any time. Now it says write down a recurrence relation model for the value of Brian's loan if the interest amount is compounded yearly. So this means PPY equals 1. So if we go and we write this one out, so if we use our formula again, okay, so this is our recurrence formula for compound interest. So we've found it here. So if I'm doing the first one, you can see I've got to write VO, because when you write a recurrence relation, you always got to write VO, so 5,000. And then I've got to write the Vn plus 1 rule, which means I will use this formula here. So in this case, in this scenario, I'm just going to calculate the R separately, and then I'll pop it into the formula. So it's 1 plus the rate over PPY over 100. So in this example, it's 1 plus the rate, which is 4.5, over 1, because yearly is 1, over 100, and equals 1.045. So when I write the recurrence formula over here, it'd be 1.045 times Vn. Okay? So this would be the answer to that one. Now, so when we're doing the B, question B, so PPY is quarterly, so that means 4. So we write the VO, and then we write the Vn plus 1. Now we did, when we calculated the R this time, we did 1 plus 4.5 over 4 over 100, which equaled 1.01125. So when we write this formula here, this one, that's what we've got to have. We've got a 1.01125 times Vn, okay? So that is the recurrence relation when you have all of that written. And then our last one, C, when it says monthly, what's PPY then? Is 12, good. So I'll quickly work the R out first. So R would be 1 plus 4.5 divided by 12 over 100. And that equals 1.00375. So when I write this recurrence relation, VO is 5,000, Vn plus 1 is 1.00375 times Vn. Oops, sorry, that's not Vn. And that's what you need. Okay, an investment of 6,000 earns, so here, 6,000 is our VO, earns compound interest of 4.2% per annum. A recurrence relation can be used to model it after n years. So here, that's a recurrence relation. So you can see they put both VO and the rule. And it says in the recurrence relation, use that to find the value after 1, 2, or 3 years. So here is where we type in the first one and we press enter. And what you'll see when you actually do this, when you press times, answer will come up and you'll say times 1.042, and then you press enter and you'll get this. And then all you have to do is keep pressing enter and you'll get the following things. So if they say show, this is what you've got to write out. Yeah, you've got to show it and you'll have to write it out like that. Okay, then it says determine how many years it will take it first to exceed 8,000. So you can just keep pressing in your calculator. So we got to, this was 1, 2, so here was, what was this? 2, 3, 4, 5, 6, and you saw 7. So we said after 7 years, we got to it. So we were just quickly pressing enter in our calc. Okay, write down the rule for the value of the nth term of the 10,000 investment of an account following the recurrence relation. So now they're asking us for the nth term. So if you remember, it's the middle column. And so I've gone and grabbed the formula. This is the nth term formula for compound interest, okay? So we can see it's compound interest because it is the recurrence relation. It's got a timesing one. So when you're timesing, that's compound. All right, so if you look, now if you remember this part, the number that we have there, that was our capital R, yeah? So that was our R value. So when I have to write the nth term formula, what I'm going to do is I'm going to write Vn. Now I'm going to actually write the R, which was 1.09. Now you write to the power of n. So when you're finding the nth term in compound, it's actually the power. So you know like how we have squared? It's going to be up there, the power number. And then we're going to times it by VO. So in this case, VO was 10,000. So this is my nth term formula, okay? So here's my nth term formula, I've done that. So then when it asks me, and this is a yearly formula, then it says find V4. So if I'm finding V4, what I'm actually doing is I'm writing out that rule and it's going to be to the power of 4 there. So V4 means n equals 4. Okay, and then times by 10,000. So give that a go on your calculator and see if you get the answer right. Okay, so this, we got 14,115.81. Why am I only writing 2 decimal places? Because there was definitely more than 2 decimal places. Why am I only doing 2 decimal places? Only doing 2 decimal places, why? Because we're talking about what? We're only doing 2 decimal places because it's money. Yeah? And what's our lowest denominator, or lowest value thing in money? We talk in? Cents. Yeah, so that is cents, isn't it? So we don't go past 2 decimal places when we're talking about money. They might not tell you that. You have to know that now. Okay, so it says find the interest. Can you guys cross this out? I'm going to just say find the interest earned. Can we make that? I'm going to say after 4 years. Just we'll go a bit more simpler at the start. So if we want to find the interest, so we're going to write this. Interest the amount of interest equals the final value minus the VO. So if we looked, we found the value at 4 years. So we'd find V4 minus VO. So we do 14,115.81 minus the 10,000. So how much interest did they make? It's pretty self-explanatory, yeah? So they've got is the interest, yeah? It's how much extra they've gained. All right, it says if the interest compounds monthly instead of yearly. So really the rate before was 9% per annum. So I'll just tell you that, okay? So if you look back when they calculated the R, the little r was 9% per annum. So it says write down the value, a rule for the value, so after n months. So what we're going to do, we're still going to use that same formula, which was Vn equals r to the power of n times VO. Okay, but we have to work out, we've got a new R value, because remember R is found by doing over PPY over 100. So in this example, now we're changing the 9. Now we want to do per month. So how many what's PPY if there's months? How many times in a year? Yeah, 12. So we're going to do divide by 12 over 100. So let's pop that in your calculator and see if you get what I... Okay, so I've worked out that, so if I'm writing the nth term for a monthly formula, it's going to be 1.0075 now, because this is monthly, and then still times the same amount. What was it initially? I've got it on the other page. So it's times 10,000. So use the formula to find the investment after 4 years. If it's 4 years, how many months is 4 years?
48.
Yep.
48.
All right, so n must be 12 months times 4, so 48. So when we go to find this, it's going to be 1.0075 to the power of 48 times 10,000. Okay, so we did to the power of 48 and we saw this. So that was if you compound it monthly instead of yearly, which one gave you more money? If we look here, even though it was still 4 years, monthly did. So the more you compound it, more often, the better it is for you. Okay, so how many years will it take the investment of 2,000 paying compound interest of 6% per annum to grow to 3,000? Write your answer in the nearest year. So they've given you an nth term scenario. So we want Vn to equal 2,000 and that's VO. Sorry, we want VO. That's VO, and we want this Vn to equal 3,000, and we want to know how long that'll take us. So let's just write the nth term formula for this scenario, which would be, all right, the R would be 1 plus the rate, which is 6 over 1 over 100 times 3,000. So if I simplified that out, it's going to be 1.06 times 3,000. Okay, that's the, to the power of n, sorry. That is the nth term formula. So what I'm saying now is in this question, we want Vn to be 3,000. So I'm going to write 3,000 equals, I'm going to write the rule. And when I write that rule out, what's the only thing I don't know what it is? N. So what? Solve. Yeah, good. We can do solve. So let's find out what that is. This should be 2,000.
Yeah,
Good work, Stephen. Sorry, that's 2,000. Work that out. Okay, so when I solved that, I got 6.96. So how long does it take to grow? if you go to 6.96 years, that's when it hits 3,000. So I have to always go above. So what am I going to say? Yeah, good. So therefore, 7 years is the answer, okay?